Thank you, Eduardo. Hello, everyone. Today, I'm going to be talking about a new interface for the C++ Fastjet library. And for those who don't know, the C++ library called Fastjet is used to perform jet finding on particle data. And there are several Python interfaces currently available for it, but there are some shortcomings that we wanted to address. So we came up with this new interface. Uh, what this interface does is uses several new SCIKIT-HEP technologies that have come up recently, some of which that you heard about in the last talk, and we use that to address these issues really. So what this means is that now soon you'll be able to pip install Fastjet. So this will be the first time that the official Fastjet bindings will be available through PyPy. Also, this package comes with all the bells and whistles of the C++ version of Fastjet. So that means that all the plugins, all the algorithms, and the CGAL support is enabled as well. And also, we intend to add FJ contrib in the future as well, but that will have to come at a later date because of the technical constraints that we face. So now let's move on to PyJet. PyJet is a popular Python package for using Fastjet with NumPy. It's currently available under SCIKIT-HEP, and it uses NumPy arrays to provide event-level vectorization. However, it has two problems. The first is that it takes multiple function calls to process multiple events. And the second is that it uses FJ core. That's the header version of the C++ library of Fastjet. And the problem is that if you compare the core library and the main library and FJ core, the results are different. So that is a problem. So here's an example run of PyJet. What I'm doing here is simply importing the test data, putting it into the cluster class, and extracting 3 exclusive jets. As you can see, these are 3 pseudo jets that it produced. This is sort of how the PyJet interface works, and this is what's available under SCIKIT-HEP now. So the two problems that I mentioned, how does the new interface solve them? Well, for the first problem, we use awkward arrays. You must have heard about it just now, actually. Awkward array is a Python library used to handle jagged arrays, really, and that helps us in handling multi-event cases here. Also, to solve the second problem, we have used the full Fastjet C++ library. We're not using the header version called FJ code. We're putting the full Fastjet C++ library on the Python wheel. So in this image here, you can see sort of describing what really happens. This classic interface here represents really the C++ interface and a Python interface that is available with the C++ library. And as you can see, these small chunks are really particles, and individual particles are used as a Python object, and then they're put together in a list, and then the jet finding is performed. However, in PyJet, what you find is that the whole event is treated as one Python object, which what I mean to say is that there is event level vectorization. But as you move down the axis, you see this new interface that we are making. It provides multi-level vectorization. So the multiple events can now be treated as a single Python object. So talking about this new Fastjet interface, there are really two interfaces within this interface. One is the classic interface, which was taken from the C++ library, which is generated by the C++ library, and you can compile it using that. And the next one, new one, is the vectorized interface, which uses awkward to really handle the data. So I'll give short examples of both kinds of interfaces here. The first is obviously the classic interface. It's written in Swig, which is a tool used to bind C++ classes and functions in Python. And you can, as I mentioned before, download and compile it from the C++ version of Fastjet yourself. We've put it on the wheel because it was easy enough to put it there, and it provides an alternative to people who want to use such an interface. So I'll just run the cells here. And as you can see, it works very similarly to how the C++ version works. Here's a jet definition that I'm defining. Here is a list of pseudojets, and then I'm putting them into the cluster sequence class and extracting inclusive jets from that. Very straightforward. And so what I want you to notice here is that two things. Well, the first is that it does things one event at a time. And second is that things are done almost similarly to how they're done in C++, which is using a jet definition and making a list of pseudojets. Well, in the case of C++, it was a vector of pseudojets, but yeah. So what's different in the new vectorized interface? Well, first thing is that it uses awkward arrays, and the inputs are primarily awkward arrays and also the outputs. Wherever you need an output of, wherever the output is an array, we use awkward arrays. And the Python classic interface and the awkward interface also have a big overlap. So that means that we have reused some clustering specification classes for this as well. I'll show you what that means in a minute. Here's an example of awkward array. There are multiple events in this, as you can see. The first event has 3 particles, the second has none, the third has 4 particles, and the last has 1 particle. So running this cell, and now we go to the cluster sequence class. So as you will notice here, I'm using the same cluster sequence class and the same jet definition instance. All that has changed is the data type of the input array, which is now an awkward array. So I'll run this here, and you can see the inclusive jets are extracted just as easily. But this time they're an awkward array because this was a multi-event case. Now, if you look at the type here, what this says is that there are 4 events, each with a variable number of jets, and each jet is a specific record type. Same when you go to extract the constituents, what happens is you get awkward arrays, but this time there's an extra dimensionality added to it because now you're finding constituents of each jet. So if you look at the type here, what this says is there are 4 events. Each event has a different number of jets. Each jet has different number of constituents, and each constituent is a specific record type. So this is what's happening here. And another thing I want you to notice is that this extra field has been there from the beginning. It was in the input data that went into the cluster sequence class, and it's there in the constituents. So what happened was the cluster sequence class kind of ignored it and just used whatever it wanted to use, what it needed to use, and perform jet clustering on it. So now I can use this extra field or parameter here to calculate a charge of a jet. Really, and due to using awkward array, it's really easy in Python. And as you can see, it has calculated the charge for each jet. And really, the point I wanted to make was that using awkward arrays, data manipulation is very easy. And actually, it was never this easy. So also, when we talk of awkward arrays as the mode of input, we have to ditch pseudojet class. So something has to take its place. So that brings us to vector. This is a new Python library which is really made for 2D, 3D, and Lorentz vectors with a physics application in mind. So I'll show you an example of how an input awkward array can be in a different coordinate system and still be a valid input, like here. So I'm sorry, I have to import awkward, import vector, register awkward, and then give this name momentum 4D, and that's it. Now you can perform jet analysis on this easily. It doesn't need to be in a PXPY-PZ coordinate system. So in conclusion, I would say that, well, you can pip install Fastjet very soon. There's multi-event vectorized clustering now, and also handling the data was never this easy. That was it from my side. Thank you.
Thanks very much, Arjan. It is on time. So we have probably time for 1 or 2 quick questions. Have you got Slido in, or shall I do?
Yeah. Okay. Yeah. Was the time scale for first release in PyPy with the basic functionality available? So basically being able to do what PyJet does at present. Actually, we're very close to the first pre-release right now. And really, it should be a matter of weeks before we're able to release this as a release candidate. And from there on out, as we add functionality to it, maybe new releases will come. But beyond that, I'm not really sure of the release time structure. Using Fastjet plugins is just about recompiling Fastjet, including them. I'm not sure what you mean. We compile with all the plugins enabled when this library, when this Python package is compiled at source, and so they're available throughout the whatever. If you pip install them, all the plugins are available. If I got the question wrong, you can maybe send it on Slack again.